In this video, we're going to talk about the remainder operator in Java. So for integer operands, the remainder operator is going to give you the remainder when the first integer is divided by the second one. And so the it's related to division, but it's not like division. It's you do the division and then you get the remainder as the answer. So let's take a look at an example here. Let's say we had 14 remainder 5, and I have this app that I found that will show you how to do it. Just regular long division is what this one is for, and you have to ignore Chucky over here. So we want to divide 14 by 5, and we don't want the actual quotient that you normally have with division. What we want is the remainder, right? And so how that would work is you would just kind of do the long division work, right? To do the long division work, we would divide 14 into 5, right? So 5 doesn't go into 1, so I put a 0 there, right? Or however you want to do it. Just skip over to the next one or bring that down. 5 goes into 14 2 times, right? And then 5 times 2 is 10. Okay. And so then you would subtract. 14 minus 10 is 4. And so that would be the answer for 14 remainder 5. In other words, right, it gives you the remainder when 14 is divided by 5. Okay. In Java, that would look like this. I'm going to go ahead and write it like so. And then when we run it, we'll see that the very first one is that 4 that we got right here. Okay, so that's exactly what the remainder operator is. It's the remainder when you divide 14 by 5. So on the test, I will ask you to compute some of these. If you do it by hand, right, then you would just do the long division and then get the remainder, kind of the old-fashioned way to do it. There is a way to do it with just a calculator, and I'll show you the steps for that. On a calculator, right, it doesn't, a regular calculator, the kind that you'll be allowed to use on the test, there's no remainder key or anything like that. So with a calculator, if you don't want to do it by hand, you would do 14 divided by 5. Oops, something went wrong there. All right, 14 divided by 5. All right, there we go. And then get rid of this whole number part. So on a regular calculator, you would just do that minus the whole number part, the part to the left of the decimal place. You get 0.8. And then take that number you get and times it back by the number that you divided by. So that would be times 5. And that will come out to be the remainder. So we can see we have 4 here. So do regular division, chop off the whole number part, and then times it back by that number. That will always give you the remainder, at least for positive numbers, which is all we're really going to worry about on the test. Okay. All right, let's look at some other examples that we have here in the code. All right, and compile it and run it. I think it was okay, but just do it again. All right, and the main examples I care are these first 4 examples right here. So 14 divided by 5, we just did that one. We know that we come out to get 4. On this one, right, 7 remainder 5, that would come out to be 2. Okay, so again, going back through these other things, if you did the long division, right, 7 remainder 5, right, 5 goes into 7 1 times 5 is 5. 7 minus 5 is 2. If you did it the calculator way, right, you do 7 divided by 5. And then, oops, I know what I did. Forgot to hit that. And then subtract off the whole number part. And then times that by what you're dividing by. You get 2. Just like Java got, right? The next one is 5 remainder 7, right? So 7 goes into 5 0 times, and then you're going to have 5 left over again, right? So by hand, it would be 5 divided by 7. All right, so 7 goes into 5 0 times. Put a 0 up there. 0 times 7 is 0. Put that here, subtract, and you get 5 as the remainder. On the calculator, right, it would be 5 divided by 7. And here there's no whole number part, right? So there's nothing to subtract off. I guess you could do this minus 0 if you wanted to be consistent. And then times the result back by 7. Oops. And we get 5. All right, let's see the last example. Is 46 divided by 11. So 46 divided by 11. So 11 goes into 46, right, 4 times. 4 times 11 is 44. Subtract. You get 2 as the remainder, so that should come out to be 2. And that's exactly what Java has there. And on the calculator one more time. 46 divided by 11. Subtract off the whole number part. And times back by the number that you were dividing by. You get 2. Okay. So that is the most important parts of the remainder operator. Again, one of the main uses for this is in dealing with times. If say for instance, if you had a time, like you say it was 7 o'clock, right? And then you wanted to know what the time would be 10 hours later, right? So 7 plus 10 would be 17. And then if you did remainder 12, you would get 5. So 10 hours after 7 would be 5 o'clock. So that's one of the main uses for this, is in dealing with things like clock arithmetic and time and stuff like that. It's really useful for those kinds of things. The other examples are not really that important. Here I'm doing it with negative numbers, and the main thing is, if you're a math person, a math major, just know that that's not consistent with the mathematical definition that we use. 0 remainder 5 is okay. You'll come up with 0. If you try to do something remainder 0, though, you will get an error, and that will cause an exception or runtime error. And you can use these with doubles as well, but I hardly ever see that done. Mostly just see it used in this manner here. All right, so that's it for the remainder.